NASA's Hubble Space Telescope has observed an inbound comet unlike any we've seen before, that already is expelling gas and dust at an enormous distance from the Sun. This makes the comet a record breaker, since usually active comets aren't discovered until they're closer to the Sun and warmer. When trying to learn about our early solar system and the exact conditions of the materials that went on to form our Sun and planets, scientists try to find the most primitive objects they can, objects that haven't been disturbed by geologic activity, strong radiation, or outside forces at any point in the past 4.6 billion years. These primitive objects include asteroids and comets. Comets are more icy than asteroids, and when they get close to the Sun, the ices sublimate, go from solid to gas, and release dust that forms the comet's iconic coma and tail. We call this an active comet. Once the comet has orbited close to the Sun multiple times, it's no longer as primitive as it once was, but every once in a while, we catch a comet coming into the inner solar system for the first time, kicked out of its home in the outer solar system. These first-time inner solar system visitors give us a chance to observe a more pristine leftover from the early days of planet formation. A comet named K2 was discovered in May 2017 by the Pan-STARRS telescope in Hawaii. Hubble then pointed its camera at the icy visitor in late June, revealing this image of its 80,000-mile-wide dust cloud coma. Researchers estimate that the nucleus, the actual solid body inside, is less than 12 miles wide, and that the comet came from trillions of miles away from the Oort Cloud at the far periphery of our solar system. Astronomers don't usually discover active inbound comets until they're well within the orbit of Jupiter, but Comet K2, at the time of this Hubble image, was out past the orbit of Saturn. After discovery, researchers went back through archival images and found that K2's coma was actually visible back in 2013, when the comet was way out between the orbits of Uranus and Neptune. So why is Comet K2 active so early? Usually astronomers see comets that are activated by the sublimation of water ice, which requires relatively warm temperatures. Researchers think that K2 must be so primitive that it still has frozen volatile gases like nitrogen, carbon dioxide, and carbon monoxide, which sublimate at much cooler temperatures and are sublimating right now on K2. The lead researcher on the study thinks that K2 is the most primitive comet we've ever seen. However, compositionally, K2 probably isn't a particularly unusual comet. It's just been difficult to discover comets that far away. Even though its coma is almost as large as Jupiter, K2 is still about 40 times fainter than Pluto, and discovering a moving object that faint requires improved technology. Survey programs like Pan-STARRS should allow us to discover more and more of these faint, distant comets like K2. Since we are able to see Comet K2 so early, we'll have another 5 years to study the comet before it reaches its closest approach to the Sun, just beyond the orbit of Mars. During that time, scientists will be able to study this visitor from the remote past with ground-based telescopes, Hubble, and the soon-to-be-launched James Webb Space Telescope. Once K2 swings by the Sun, it will begin its outward journey, and K2's trajectory will actually have it leave our solar system forever. Humanity will never see this particular comet again.